let's begin. It's my first time on a stage like this, in a theater. It's awesome to be here. Yeah, pretty excited to be here to show you just a little bit about Mu. It's a library that we have built at 47 degrees, and we have put a lot of effort and love on it. So I will guide through the motivations that leads to build this library. But first of all, please let me make some poll. I can see not much from here, but I want to ask how many of you have some kind of experience building microservices? Yeah. So what about RESTful APIs on HTTP? RPC microservices? Pretty awesome. I need to ask some kind of experience with Mu, or it was called Freestyle RPC? Okay, let's change that. So, a couple of years ago, I mean, some of you probably will be asking to yourself the same questions. I asked to myself a couple of years ago when two teammates, Juan Pedro and Raúl, started to work on more than 2 years ago, but they started to work on a new library. I was involved in the discussion, in the structured decisions, PRs, and things like that. So I started to ask myself this question because I was a Scala developer. I feel pretty comfortable building HTTP services. They work pretty well. I'm still doing. But so I started to search across internet the difference between what is the difference between building a RESTful API and RPC, and what are the scenarios where it fits better one or another. So let's start by defining or settle down some concepts that I'm going to use in the talk. So the first thing is that a RESTful or a REST is a representational state transfer. It's not a protocol, right? Or it's not a tool set. It's just like an approach for building an HTTP microservice. RPC is a broad concept that stands for remote procedure call. It makes reference when a compute program executes a remote call to be executed in a remote address in the same network, right? So for Go, I'm going to use the gRPC term to compare with RESTful, because gRPC, it's a platform, RPC platform developed by Google, and right now is maintained by the community, and allows you to build RPC microservices. Mu is built on top of gRPC. So I'm going to compare the approach of building microservices with REST and with gRPC. So the first difference that I put here is how they address a business logic per each. How they address the business logic. So when you are working with a REST API, you usually translate the domain into resources, right? These resources are identified by URLs. And you map directly the HTTP verbs into CRUD operations. Probably all of you know that this is not an easy thing. So sometimes you find some cases, some use cases where these HTTP verbs didn't match pretty well, right, in the scenario. So with gRPC, we don't have this kind of resources. We have clearly interface that map directly into business logic. So this is just, we can see that in this first difference is a big difference when you need to build something. The second difference is the protocol. RESTful APIs use HTTP 1.x, usually 1.1, and it's a textual protocol. It embraces the request response model. In gRPC, on the other hand, we are using HTTP2. HTTP2 tries to, keeping the semantics of the HTTP1, but try to simplify the communications, the wire. So they added this concept called multiplex streams that allows you, for example, to reuse a single TCP connection between multiple streams. I'm not gonna go into details. In the protocol, it deserves its own talk. But yeah, it's a huge difference. It put the difference that we are using textual versus binary. And this leads to the third difference, that is the pilot format. We have seen that the RESTful API using textual, gRPC is binary. So with RESTful API, we usually use JSON, and with gRPC, we have strongly typed messages. This typed messages sounds good, right? We work with functional programming, we like this kind of thing, that the things are strong typed. The good thing about this is that by nature, by how we develop services with gRPC, these messages are automatically converted. And this is extremely hard to achieve in HTTP. There are tools. We have seen one of them that do a great job, but from my experience, companies usually don't achieve the automatically conversion, for example, create clients based on the format. So this is something that we gain with gRPC. One of the drawbacks, probably you know, for those that have been working on gRPC, is that with the RESTful API, it's very easy to test them. So with gRPC, it's very hard because you can't write some text, arbitrary text, and sending with curl or with Postman or with other tools like that. You need a program that converts into a binary message. This leads also to the first difference, that is the contract definition, right? When we are developing RESTful APIs, we can do two approaches. We can define the contract first, or we can define the contract last. In large team, we usually define the contract first, then develop in a parallel way, probably the clients and the server. In gRPC, it's strongly contract first because the thing that we have seen before, that the messages are strongly typed and needs this schema to generate the stubs for the client and for the server. So this is kind of comparable or equivalent with the previous difference. And to finalize, I want to put this, that is the different communication that supports natively the protocol. So in RESTful, by default, we have that we have synchronous communication and unary communication, and we can, of course, have this kind of libraries on top of that provides some streaming communications, and also asynchronous. But the protocol, the gRPC protocol HTTP2 supports natively asynchronous and support also not only unary, also server streaming, client streaming, and bidirectional streaming. Sorry. So these are the difference and similarities that I have put in this talk too. And I hope that they can be used to find like use case where you can find that gRPC can be a better approach for different things. You don't need to choose one or another in a system. You can have both integrated. But usually the first thing that you find when try to look at difference between a RESTful API and gRPC is the performance, right? And the performance is not an exact measure because it depends in a lot of factors. It's not the same that use one HTTP client than another. Someone have more performance, or for example, the serialization library, and things like that. So at 47, we have built a project called Metrifier that compares HTTP4S with mu, and using a couple of serialization mechanisms, using protobuf and agro. We will see more about this serialization mechanism in the next slides, but basically there are different ways to serialize. As you can see, the gRPC performs much better. This is a stats from some benchmarks executed in Google Cloud. So there are some key aspects that allows you to understand these results. For example, as I said, because the protocol, the long life connections performs better in gRPC because it allows reuse a single TCP connection. Of course, the payload format is textual versus binary, and serialized binary messages is more efficient. On the other hand, for a single connection, if you have some kind of benchmark that tests each single connection, you could get a worse performance because it adds an extra, like security and other constraints on the header. Lastly, well, sometimes the cache is more advanced in a RESTful API. So we have seen some difference between the RESTful API and gRPC, at least what I put there. Now we are going to enter in a second part of the talk that I will try to describe the motivation and how is mu built. So let's start by saying what is not mu. Mu is not a transport layer library, it's not a serialization library, and it's not a program for executing gRPC call. So what is mu? Mu is a framework for building functional RPC services. And I left RPC there, but I was tempted to remove, because we have now some experimental features that allow you to build not only RPC service, but also HTTP service. These are still experimental, but they work well. Also, it's not only for services, it allows you to auto-generate clients based on protocols. And as you can see here, I'm not using the RPC because we support right now a small subset of open API specification. So you can build clients based on this specification. So this is mu. And mu, as I said at the beginning, started like a couple of years ago, a bit more. I generated this stat. They are not very useful, but I put it to that you can see the timeline when it started. We have like some contributors, more than 20, things like that. We are very pretty excited about the library because we have put this library already in production, and it has been well proven that it's working. It provides a good performance and a value for some companies. So dependencies. When we have seen what is mu and some difference about gRPC and RESTful API. So we maybe consider to adding this library to our system or to our technology stack. So at least for me, when I'm considering adding a new library, one of the first things that I look at is the dependencies, because at the end you will be tied to its dependencies, right? It's also a way to see how is built that library. So I have prepared this diagram with the dependencies that you will see. There are others, but for working internally. But these are the dependencies that you will see when working with mu. So I said at the beginning, mu is built on top of gRPC, and we are using gRPC Java. That is the library for building the gRPC services in the JVM. And we have put a functional layer on top of that using catch effect. So you will be like dealing with the catch effect classes mostly the time. Besides on the serialization mechanism that you use, you will use, we support Avro and Protobuf out of the box. You can have other serialization mechanism with some effort, but out of the box we provide support for Avro and for Protobuf. And we use these two libraries for the serialization, Avro4S and PV Direct. And we also did do some kind of code generation that we are going to see later. And we use these two libraries for the code generation. AvroHugger for generate things related with Avro, and Skewmore, that is a library that we have developed also at 47, allows you to make some transformation between schemas. So we probably move all the Avro generator with Skewmore in the future. And we have some experimental feature to build a HTTP server, HTTP clients, and we use HTTP4S. And for streaming, you can use Monix or you can use FS2. And just to finalize this slide, we support metrics, and we have out-of-the-box support for Prometheus and Dropwizard. But you can provide also your own metrics. So, okay, this is more or less Mu. I hope someone, all of you have a clear idea about what Mu is or what are their ideas. And we will see the steps for creating Mu. In Mu, there are a lot of features related with clients, server, channel. We have some features for cache, for metrics, interceptors, and things like that. And there are a lot of use cases that you can use the Mu only some parts. But for building a RPC microservice, we recommend a series of steps. I have put these steps here because it's the recommended way to build a RPC microservice with Mu. So the first thing that we need to do is to create our contracts. I put here IDL version contracts. IDL stands for Interface Description Language. It's not making a reference to a specific language. It's just choose the serialization mechanism and define your models and your services using that language, right? In a standard way. And it's versioned because we want to evolve our service, right? This serialization mechanism provides his own steps for evolve the services. And they will tell you what change is forward compatible, what is backward compatible, or what is breaking the compatibility. So once you have defined your contracts, you will use the MuSVT plugin to auto-generate a Scala definition. And this is why I said that this is the recommended way, because you can skip the step of the MuSVT plugin and go directly with the Scala definition. Because at the end are Scala classes or Scala files where you will have case classes, trace defining your services with some annotation that you need to put on them. But if you skip that step and go directly with the Scala definition, you will be tied to Mu in your infrastructure, right? You will be, when you need to share the contract, you will be sharing a Scala class, probably in a jar. And this is very, very dangerous because you are not only sharing that Scala definition, you are also sharing that its dependencies. And you will be tying the ones that want to use, for example, want to create clients based on those schema. They will be dependent of the dependencies for that schema, causing probably, when you grade something, some binary incompatibilities. So if you define the contracts in an IDL, you can share these text files with the clients or with other server, and your system will be tied to the protocol that you are using. That is better, in my opinion. Also, you are not making all the people using Mu. For example, you can share the contracts and let the client be auto-generated using GoTo or Kotlin or something like that, because they are based on a standard contract. So once we have this Scala definition, auto-generated or not, we have some utility methods to build and to start a server, and also to build and use clients. So let's build a service. I have created this sample project. It's available on GitHub, so don't worry about all the code. I have also cut down some parts to make it more friendly. But I created this to-do list service. We are going to create a simple service that we have like 3 methods. One method for creating a to-do item, another one for getting a to-do item based on ID, and the last one to get all the items. This last method will be like server streaming. So the first thing is we need to choose a serialization mechanism. And I said that gRPC Java supports any serialization mechanism that you want. You can just implement some interfaces and use the one you want. And with Mu, it's more or less the same. You need to implement the threads and just provide the implicit instances. But because the power of Scala allows you to provide out-of-the-box serialization mechanism. And we provide out-of-the-box protobuf and Avro. You just need to have case classes. If you specify Avro or protobuf, they will be automatically, we will provide automatically serializator and deserializator for that case classes. So there are some slight differences. Protobuf is the serialization mechanism by Google. Almost every communication made internally between the Google services is made through protobuf and is very performant. Usually, the schema is needed in both places. You need the schema to generate the clients for reading the data, and also you need the schema in the server. So it's a feature that is not the same with Avro, that was developed as part of the Hadoop project, so we can see that is the Apache's serialization mechanism. Sometimes, usually the schema is embedded inside of the message. So you read the first bytes and have the schema, and then process the message. It's not always, and it's not mandatory to do it that way. So, okay, we have put, as I said at the beginning, we have put Mu in production, and we have also always used Avro because of the requirements of the project. So on each open source project that we usually do, we choose protobuf in order to improve the support of Mu for that protocol. So for that sample, I have also choose protobuf, and also Avro doesn't support natively stream. And I wanted to show just a bit about the stream, so I choose protobuf. But in the sample project that I put it in GitHub, there is also the Avro definition, and you can use Avro too, removing the last method. So I'm not going to go into the details about creating a contract in protobuf, because the proto language. It ends in the .proto extension file name. Well, just a couple of things. You put the syntax. I'm using here proto2 because we have detected some issues with coproducts in PB Direct. So we have, in this case, some incompatibilities between Mu and PB generating coproducts. So I have chosen here proto2, but you can choose proto3 if you are not going to use one-off constructions. Put the package and the message. You need to specify the fields, the type, some index that allows you to build to make changes in your services and make it compatible. So then we define the service. It's pretty straightforward. You put the RPC keyword, the request, and the response. The only thing here is that I'm using here a stream. So in the get to-do item list, I'm returning a string of to-do items. So we have the contracts, and we can package these contracts in a jar file and share freely with the other teams, and they can use different versions of Mu, of different versions of other technology to build their clients. But for our Mu perspective, we are going to, as we saw in the recommended step for generating a RPC microservice, we are going to generate the Scala code. And I have said that we need an SVT plugin. So we need to add an SVT plugin in the plugin.svt file, and that puts some settings, some SVT settings in place. So here I'm saying that this is a task from Mu, and I attaching that task to the source generator task available in the SVT build cycle. So each time that we compile the project, it will first generate if they are not generated, they will generate the Scala code based on the contracts. I specifying here the ideal type that we are going to read is proto. I'm specifying here the output. Usually it's the same if you don't want to mess things. I have just put in some dependencies. Channel is like the main dependency for using communications, and FS2. So with that in place, when we compile the project, based on the contract that we had defined in Proto, Mu will generate these case classes for your models, for example. So this is what I said at the beginning. We can skip this part and just go for this. But it's better to have our infrastructure communication defined in a standard language, right? Leave these kind of things to work internally. So the plugin will generate this thing for your, it will generate case classes for your messages, and it will generate a trait polymorphic over F with some macro definition that we are gonna see what provides. Is not very complex, but it's a macro definition that do some things for you with the protocol that we have chosen, and identity is a keyword that is used gRPC that for saying that we are not compressing the communication, we are using the identity. And we have the three methods that we have defined in the schema. So nothing special here. You have like a tray, a taglet final. How many of you are familiar with the taglet final? So great. So it's just like a taglet final algebra over F. Yeah, we can see here that have put the stream for that method. So, okay, let's add the implementation. It's very straightforward. We just need to provide an implementation for that algebra that will be used in the server to provide the body or the business logic for us. So I have not added the body because, I added at the beginning, but I just created an in-memory service. This is not very pretty useful, and you will probably want to not use an in-memory thing. You probably want to receive some connection to the database, some algebra with your connection, and build some business logic here for creating, getting, and get the list. But yeah, I leave the main builder to show you how we can start the server later, right? So yeah, I'm using here. This is available in the GitHub sample project. It's using ref. Fabio is gonna talk more about this object that is in Cat's effect library. But yeah, I have lived this and implemented. So let's start the server. You will see that it's not a hard thing. We have this, as I said, some utilities coming from the macro. Sorry. So if you remember in the trait, polymorphic over F, we had this macro definition. And what is macro doing? This macro creates a companion object with some utility methods. We will see another one later, but right now we want this method. He creates a bind service methods, polymorphic over F, but with the constraint of concurrent effect, and it also requires implicitly an implementation of the algebra. And it will create a server service definition, which is an object from mu. So with that method, we also have an object available in mu called gRPC server that has, for example, a method called default that receives a port, a list of configurations that this is a salt trait, and one of these childs of this salt trait is at service that receives a server service definition, and it builds a server over F. So it's like side effects for creating a server. You have other methods for passing other kind of configurations, right? But this is the default one. And we also have a server method, constrained over effect, that receives the server and return unit because it starts the server. You can do with the internal methods from gRPC server, but we have this also utility methods. So we can just figure out how we can start the server, right? We will need an implementation. We need to build an implementation, right? We can use the default method to create a server and then call start or call server, sorry. So this is the for comprehension for that. Build the algebra, bind the service that generates the service definition, pass it to the gRPC builder, and just start the server. So with that, we have just a gRPC server running in the background with our implementation. So, okay, we have the server. We want to call the server in our programs. So another utility method that the macro generates for us is the method client. So client is also polymorphic over F, and it receives, it has the constraint that you need to provide a concurrent effect and also a context shift. You need to provide a channel for, which is a cell trait with different kind of configurations for the channel. It receives a configuration for the, this is for the connection. This is some configuration for the channel, and we also have some configuration for the call itself. This is directly an object from gRPC, but they have some values by default. For example, we can, by default, is plain text and using the default options. And this generates an object from catch effect that is resource. It generates a resource over F with all algebra. So this method will give us a resource of an implementation of your algebra. So you can mix gRPC calls inside of your other taglet final programs, right? So you can just treat the client as it was another algebra from your program. Let's see. I have put again the survey to refresh what methods we have. We know that each method returns a side effect. So let's use it. We have this, well, I don't know How many of you know the resource type from Cat's effect? Okay. Well, a resource is a type in Cat's effect that wraps a resource allows you to use the resource, and it will it will close the resources for you attached to that resource. So we have these utility methods used, and it receives here a function from A, from the resource, to the method that we have here, the F that we have here. In this case, I'm using IO. We need a function that goes from the resource type to IO of A, so anything encapsulated in IO. So I'm just using the client here. I'm creating a new to-do item, getting a to-do item, and getting a list. I'm compiling to list because it's a string. So look at how easy it is interact with this algebra that is internally making a connection, an RPC connection for you. So to summarize, we have defined our services in a standard way, and this will save us some binary incompatibilities because we are just sharing textual protocols. We are using a well-proven framework in production, is gRPC. We define our services in a functional way, but without losing all the possibilities that the gRPC library have. So there are some new things on the road. We have Prometheus and Louisiana metrics, TLS, gRPC Java configurations, and we also have in progress OpenAPI client derivation, HTTP service, Mu Kafka. In the following months, we will be working on Mu Kotlin. So this is all I have for you. I hope you enjoy it and give a try. I'm Fede Fernandez. I work at 47 Degrees, and the project is here. So thank you. I don't know if questions?
The talk was so clear that nobody has any doubt. Okay.
Hello, thank you for the talk. Is there any chance right now to call Microservices from JS or TypeScript or any front end?
No, not right now. Probably outside of Mu, but not in the library. You can use the standard contract, right, to generate. We have some tests using GoTo, for example, calling Mu microservices. Is what you?
Yeah.
Oh, yeah, okay.
So we have to wait until the OpenAPI derivation will be there.
The OpenAPI API derivation is already in place. We just are supporting a small subset because it's pretty broad. But you can actually create HTTP for REST clients. And our idea is to support different dependency versions, like HTTP for REST, like 0.18, 0.20, and things like that.
Thank you very much.
Yeah. Welcome.
Thanks for the talk. I don't mean to be this in a polemic way. Just wanted to ask whether it would be possible to have plugins to generate the classes not using final tagless, or so using other encodings. Would that be something that is into the core of Mu, or would it be pluggable?
I'm not following right now. Yeah. Indeed,
So my understanding is that when you generate the service classes, skeletons, they are implemented, like they are generated with the finite tagless encoding. And so would it be possible to have mu not auto-generate those classes using finite tagless, but with other kind of encodings?
Yeah, I mean, we have like a feature that we want to explore is not to be tied to Katz effect. I think that is then what you are asking for. So, yeah, probably. But right now, we found that this what our clients want right now. So we have been focused on other things like mu Kafka and things like that. But yeah, we have exploring these kind of things to generate things that are and don't make you work with tagless final yes or yes. So we'll take into consideration. Thank you.
Okay. Thank you once again, Fede.
Yeah.
Thank you.